Hello, my viewers. You are welcome to my YouTube channel. Today, we are going to be doing revelation hours in physics. We are going to do a very intense revision on physics, and we are going to try as we can to summarize every aspect of physics. We have measurement of length. Okay, what are the instruments used for measuring the length of an object? What are the instruments used to measure the length of an object? The first instrument is called the meter rule. Okay, please get your paper, get your note and your pen to jot this down. Now, okay, now the first instrument for measuring length is called the meter rule. Your meter rule is used to measure, I told you, and then the measuring accuracy of a meter rule is 0.1 centimeter or 1 millimeter. Please take that down. And again, your reading accuracy of a meter rule, is 1/2 times the smallest division. Please take note of that. Your reading accuracy is 1/2 times the smallest division. Now, what is the smallest division of a meter rule? 0.1 centimeter or 1 millimeter. So that will give us, if you put 0.1 centimeter here, you will get 0.05 centimeter. Then here you will have 0.5 millimeter. So the maximum error that can be observed in a device called the meter rule is what? Is 0.05 centimeter or 0.5 millimeter. Okay, take note of that. Then the next instrument used for measuring length is called the what? The vernal caliper, or you better call it the caliper. What's the caliper used for? The caliper is a device that is used to measure the and internal diameters. It's used to measure the external and internal diameter of round object. Please take note of that. Of round object, or better still, used to measure the external diameter of cylindrical object, like the diameter of a test tube, the diameter of a rod, or the diameter of a small ball bearing. Okay, it is used to measure both external and internal diameter of a round object. Okay, please take note of that. The reading accuracy, or yeah, the reading accuracy of a vernal caliper is 0.01 centimeter or 0.1 millimeter. So get the difference between them. This is 0.1 centimeter, this is 0.01 centimeter. This one is 1 millimeter, this is 0.1 millimeter. Okay, now the next one is called the micrometer screw gauge. The micrometer screw gauge is used to measure smaller objects, such as the thickness of a paper, the thickness of. Okay, so please take note of that. This is your meter rule. It measures up to 0.1 centimeter in centimeter. That's 1 decimal place in centimeter and 1 millimeter. Take note of that. The reading accuracy is 1/2 times the smallest division. So if you see a question like the reading accuracy of a device that is graduated in centimeter is what? 1/2 times smallest division, and this is the smallest division. So if you put your 0.1 in this place, you are going to get 0.05 centimeter. Then if you put 1 here, you are going to get 0.5 millimeter. Are you getting it now? Now the caliper is used to measure internal and external diameter of round or cylindrical objects, such as the diameter of a rod, or the diameter of a test tube, okay, or the diameter of a small ball bearing. That's what you use your caliper to do. And your caliper accuracy is 0.01 centimeter or 0.1 millimeter. And then we talk about the smaller unit of length measurement. It is called the micrometer screw gauge. Micrometer screw gauge, as the word implies, micro, is used to measure the diameter of smaller objects that cannot be measured with meter rule, caliper. Okay, now it is used to measure the thickness of a paper. Take note of that. It is used to measure the diameter of a wire. Remember that the diameter of a wire is very narrow and thin. So we will have to use the micrometer screw gauge to measure such small objects. Okay, now the reading accuracy of a micrometer screw gauge is 0.001 millimeter. Take note of that. It is very, very important. Just 3 questions that we are going to answer with this topic called measurement and unit. Okay, let's take some questions. Now, the first question is this. The first question is this. The question says, Roman figure I. Question number 1. Let's take this question, please. Question 1. Okay, the question says, Roman figure I, diameter of a small ball bearing. A small ball bearing. Diameter of a small ball bearing. 2. Thickness of a paper. Thickness of a paper. Okay. 3. Roman figure III. 3 says diameter of a what? Measuring cylinder. Diameter of a measuring cylinder. And then the 4th question says the length of a piece of wire. Length of a piece of wire. Now the question says, please take note of this question number 1. It said diameter of a small ball bearing, thickness of a paper, diameter of a measuring cylinder, and length of a piece of wire. Now here is the question. Which of the following above can be measured using a micrometer screw gauge? Which of the following above can be measured using micrometer screw gauge? Okay. Option A says that Roman figure I, Roman figure II, and Roman figure B says Roman figure I and II. Option 6 says Roman figure II and III. Okay. Option D says Roman figure III and what? IV. Which of the following Okay, now here's the question. The question says, please look at the question. Question number 1 under this topic: diameter of a small ball bearing, thickness of a paper, diameter of a measuring cylinder, length of a piece of wire. Now, these are the options. The question says, which of the following above can be measured using a micrometer screw gauge? Measuring length, meter rule, caliper, and micrometer screw gauge. Meter rule, caliper, and micrometer screw gauge. Remember that meter rule is to measure lengthy objects. Your vernier caliper is used to measure diameter of round objects, like the diameter of a rod, depending on how big the rod is. or the diameter of a test tube. It can measure both internal and external diameter of round or cylindrical object, while your micrometer screw gauge is basically used to measure the diameter of smaller objects. So it can even be a round object, but if it is a smaller object that cannot be measured by vernier caliper, you can use your micrometer screw gauge. I told you that one of the object that can measure micrometer screw gauge is the thickness of a what? A paper. You know, paper is very light, so you can use it to measure it. Diameter of a wire. You know, diameter, the cross-sectional area is very narrow, so you can use micrometer screw gauge. Now, the question now says that which of the following above can be measured using the micrometer screw gauge. Now, class, listen to this. Diameter of a small ball bearing, can it be measured with a micrometer screw gauge? Yes, because the ball bearing is very small, so you can use micrometer screw gauge to measure it. Can the micrometer screw gauge measure the thickness of a paper? Yes, because paper is very what? Thin. That's why it's called micrometer screw gauge. Now, diameter of a measuring cylinder. Cylinder is big. You can use caliper, not micrometer screw gauge. Okay. Length of a piece of wire. You use your meter rule. So there are only two objects there that can be measured with your micrometer screw gauge. So that will make us to say that our answer is I and I. Okay, our answer is not A, our answer is what? B. Wonderful. Now let's take another simple question on this. Now, before we take the next phase of this question, I would like for us to talk about measurement of mass. Mass can be measured with what? Number one, beam balance. Beam balance. Number two, mass can be measured with lever balance. Number three, mass can be measured with chemical balance. So better still, you can say that mass is measured with an instrument called balances. Now, this theory instrument is based on the principles of moment. So take note, the working principle of this instrument used to measure mass is the principle of moment. Don't forget, mass is measured in what? Kilogram. And your mass is constant anywhere you go. Remember that the mass of a body remains constant. So if an object is taken from the earth to the moon, or taken from one planet to another planet, the mass of that body remains constant. Okay, take note of that. That's number two. We talked about length. Number two is mass. Then number three, it is important that we talk about what? Weight. Don't forget, weight has a formula which is mass times gravity. And your weight is measured in what? In Newton. Newton is the instrument used for measuring what? Weight. Now, weight is measured in Newton. Now, what's the device used for measuring weight? Weight is measured with a device called the spring balance. Please take note of that. The spring balance. As for mass, you have beam balance, lever balance, chemical balance. But as for weight, you have spring balance. Now, this spring balance is based on the what? Is based on Hooke's law. Please take note of that. Remember, Hooke's law states that provided the elastic limit of an elastic material is not exceeded, the force applied is directly proportional to the extension produced. So take note of this, that spring balance is based on the principles of Hooke's law. So we have talked about length, we have talked about what? Mass, and now we are talking about what? Weight. Then number four, let us talk about the volume of an object. Volume of an object. How can the volume of an object be measured? The volume of an object can be measured from two different angles. One, you can determine the volume of an object using the formula. Or better still, objects are divided into two. We have regular shaped object and we have irregular shaped objects. Now, for regular shaped objects, the volume can be determined by using the formula. For instance, how do I measure cylinder? Cylinder is measured The volume of a cylinder can be measured with the formula for the volume of a cylinder, which is V equals to pi r square h. So if you know the volume, the formula for the volume of a cylinder, you can measure the volume of a cylinder. For instance, if I'm talking about a sphere, how can I determine the volume of a sphere? You use the formula 4/3 pi r cube. If I'm talking, for instance, about a hemisphere, the formula is 2/3 pi r cube. So you can use this for cylinder, you can use this for a sphere, then you can use this for hemisphere. So what am I trying to say? The volume of an object can either be regular or irregular. If it is a regular object, simply use the formula for volume. If you know the formula for the volume of the object, you can determine the volume of that object. You don't need any measuring instrument. Now, if we now talk about the volume of an irregular shaped object, okay, if you want to measure the volume of an irregular shaped object, it is quite very easy. All you have to do is to put the object in a cylinder containing water. The volume of the water displaced out from the cylinder is equal to the volume of the object. So irregular objects are measured by inserting them into a cylinder containing water. Are we together, class? Yeah, that's very good. Now let's do this. Now let's take another question. The question says that the volume of a stone having an irregular shape can be determined with dash. The volume of a stone, the volume of a stone having an irregular shape can be determined with dash. A, meter rule. B, measuring cylinder. C, vernal caliper. D, micrometer screw gauge. Please. Now let us answer this question. Micrometer screw gauge. The volume of a stone having an irregular shape can be measured with dash. Now, what did I say earlier on in this lesson? I said that if an object has an irregular shape, if you want to determine the volume, you simply place the object into a cylinder containing water. And that's all you have to do. So the answer is not A, but the answer is what? B. Okay? Now, let's quickly rush to the next phase. Please, you have to share the link with your friends, okay? If you have anyone preparing for JAM, share the link with your friend right now. Tell him that the H2O is live so they can follow us on this channel. We are going to the next phase of today's video lesson. Now, let's take the next topic in physics. We'll call it fundamental and derived quantities. The next topic in physics is called fundamental and derived quantities. Fundamental and derived quantities. Fundamental and derived quantities. Fundamental and derived. Now, what is a fundamental quantity? A fundamental quantity is the basic quantity in physics, okay, that others depend on for their definition and expression. What am I trying to say? The fundamental quantities are the independent quantities in physics. Every other quantities depend on them for their definition and expression. So they are the basic quantities in physics. And how many are they in number? They are 7 in number. Your fundamental quantities are 7 in number. Now, I'm going to give you an acronym that will help you memorize your 7 fundamental quantities without stress. Now, what is the acronym? You spell the letter MELTA. If you can spell this letter MELTA, then you have gotten your 7 fundamental quantities. Okay, what does M represent? M represents the mass. And remember, the mass is measured in what? Kilogram. Okay. E What does E represent? E represents electric currents. Electric current is measured in ampere. Okay. What does the first L represent? It represents length, and length is measured in meter. The first T there represents time, and time is measured in seconds. The other T represents temperature, and temperature is measured in Kelvin. Temperature is measured in Kelvin. Then what do you have for A? A represents what? Luminous intensity. Wow. Please take note of this. This is your is the mass. Mass is words, kilogram. The second one is E, electric current. The first L is length and it is measured in what? Meters. T means what? Time and is measured in seconds. The other T is what? Temperature and is measured in Kelvin. L is what? Sorry, A is amount of substance and is measured in moles. Okay. Then your L is luminous intensity and is measured in candela. Please take note of that. Now, every other quantities that are not mentioned here are known as derived. So if I quantity here, derived quantities, if I'm to give you examples of derived quantity, I will say that all quantities that are not fundamental, all quantities that are not fundamental. So quantities like area is a what? A derived quantity, okay? Area is measured in meters square. Quantity like volume is a derived, and that's meter cube. Quantity like density is a derived, and that will give us kilogram per meter cube. Quantity like pressure is derived, and that will give us Newton per meter square. Quantity like temperature gradient is a derived quantity, and that will give us Kelvin per meter. Okay, there are many quantities here that are derived. You might not be able to know all the derived quantities, but yes, you can master your fundamental quantities. If you know your 7 fundamental, then any other quantity given to you should be labeled as derived quantities. Okay, please master this very well. Now, the unit given to you here for the fundamental quantity are the SI unit. That means System International Unit. So what is the SI unit for mass? Kilogram. What is the SI unit for electric current? Ampere. What is the SI unit for length? Meter. What is the SI unit of time? Seconds. What about temperature? Kelvin. What about amount of substance? Moles. Then what about luminous intensity? Candela. Okay, so every other quantities that are not fundamental are known as what? Derived. Okay, take note of that. Then I have 2 questions for you in this topic, fundamental and derived quantities. Okay, now let us quickly take these 2 questions. Okay, now the question says the international agreed system of units, the international agreed system of unit, or better still, the SI unit